Trigonometry. This new term, trigonometry, has a lot of importance in our daily life. Many of our real life situations can be linked to trigonometry. Let us imagine a situation. Suppose you and your friend have visited a tall monument. It may be ranging from a Qutub Minar to the Eiffel Tower. And your friend desires to find out the height of the monument. Is it possible just by looking at it and determining its height? You will say no. But the answer practically is yes. We can do it with the help of trigonometry. This topic is one of the most important and interesting topics in mathematics and also a scoring one. Now, let us know in detail about trigonometry and its applications. The word trigonometry is originated from the Greek words tri meaning three, gonia meaning sides and angles, and metron meaning measure. Hence, the word trigonometry means three-angled and three-sides measure. That is, it is the study of the geometrical figures which are having three angles and three sides, that is, triangles. The great Greek mathematician Hipparchus of 140 BC gave the relationship between the angles and the sides of a triangle. Further, trigonometry is developed by Indian mathematicians. It was migrated to Europe via the Arabs. Trigonometry plays an important role in the study of astronomy, surveying, navigation, and engineering. Nowadays, it is also being used to predict the stock market trends. Trigonometry revolves around right-angled triangles and the six angles known as trigonometric ratios. The angle is denoted by a Greek alphabet theta. Trigonometric ratios. Now, what are the angles which are involved in trigonometry? There are in general 6 trigonometric ratios. They are sine, cosine, tangent, and their reciprocals cosecant, secant, and cotangent respectively. Now, let us know in detail about each of these ratios. The first trigonometric ratio is sine. Sine of angle theta is defined as the opposite side divided by its hypotenuse. Sin sin is used to represent the sine of theta. Cosine. Cosine is the second trigonometric ratio. Cosine of angle theta is defined as the adjacent side divided by its hypotenuse. Cos is used to represent the cosine of angle theta. Tangent. Tangent is the third trigonometric ratio. Tangent of angle theta is defined as the opposite side divided by its adjacent side. Tan is used to represent the tangent. The fourth trigonometric ratio is cosecant. Cosecant of angle theta is defined as the hypotenuse divided by its opposite side. Cosec is used to represent the cosecant. The fifth trigonometric ratio is secant. Secant of angle theta is defined as the hypotenuse divided by its adjacent side. Sec is used to represent the secant of theta. Cotangent. Cotangent of angle theta is defined as the adjacent side divided by its opposite side. Cot is used to represent the cotangent. Relationship between all the trigonometric ratios. As we can see, sine can be expressed as the reciprocal of cosecant and cosecant can be expressed as the reciprocal of sine. Similarly, cos can be expressed as the reciprocal of secant and secant can be expressed as a reciprocal of cos, as well as tan can be expressed as a reciprocal of cot and cot can be expressed as a reciprocal of tan. Tan can also be expressed as sine by cos, and cot can also be expressed in terms of cos divided by sine. Trigonometric ratios of some specific angles. From geometry, you are already familiar with the construction of the angles of 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In this section, we will find the values of the trigonometric ratios for these angles and, of course, for 0 degrees. For all the trigonometric ratios, the values of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees have been specified. As we can see, the value of sine for 0 degrees is 0, for 30 degrees is 1 by 2, for 45 degrees it's 1 by root 2, for 60 degrees it's root 3 by 2, and for 90 degrees it's 1. Similarly, for cos, 0 degrees is 1, 30 degrees is root 3 by 2, 45 degrees is 1 by root 2, 60 degrees is 1 by 2, and 90 degrees is 0. For tan, 0 degrees is 0 by 1, that is 0. Tan 30 degrees is 1 by 2 divided by root 3 by 2, which gives us 1 by root 3. Tan 45 degrees is 1 by root 2 divided by 1 by root 2, which gives us 1. Tan 60 degrees is root 3 by 2 divided by 1 by 2, which gives us root 3. And tan 90 degrees is 1 divided by 0, which gives us the value of infinity or not defined. Similarly, for the reciprocals, cot theta is equal to 1 by tan theta. So, cot 0 degrees is 1 by 0, that is not defined. Cot 30 degrees is 1 divided by 1 by root 3, which gives us root 3. Cot 45 degrees is 1 by 1, which is 1. Cot 60 degrees is 1 by root 3. Cot 90 degrees is 1 by infinity, that is 0. For secant, which is a reciprocal of cos, we get secant 0 degrees is 1 by 1, that is 1. Secant 30 degrees is 1 divided by root 3 by 2, which is 2 by root 3. For secant 45 degrees, we have 1 divided by 1 by root 2, that is root 2. For secant 60 degrees, we have 1 divided by half, which gives us 2. For secant 90 degrees, we have 1 divided by 0, which is not defined. The last, that is the cosecant of theta, is a reciprocal of sine theta. Cosecant 0 degrees is 1 divided by 0, that is not defined, and cosecant 30 degrees is 1 divided by half, which gives us 2. Cosecant 45 degrees is 1 divided by 1 by root 2, which gives us root 2. Cosecant 60 degrees is 1 divided by root 3 by 2, which gives us 2 by root 3. And cosecant 90 degrees is 1 divided by 1, which gives us 1. From the table, it is clear that sin theta is equal to cos theta, tan theta is equal to cot theta, and secant theta is equal to cosecant theta if theta is equal to 45 degrees. That is, for angle 45 degrees, sin theta is equal to cos theta, tan theta is equal to cot theta, and secant theta is equal to cosecant theta. Secondly, sin theta and tan theta will increase with the increase in the theta value. Cos theta decreases with the decrease in the value of theta. Do you remember what are complementary angles? Two angles are said to be complementary if their sum is equal to 90 degrees. Now, in case of trigonometry, we shall write 90 degrees minus a for our convenience instead of 90 degrees minus angle a. We can find that sine of theta is equal to cos of 90 minus theta. Cos theta is equal to sine of 90 minus theta. Tan theta is equal to cot of 90 minus theta, and cot theta is equal to tan of 90 minus theta. We can also find out that cosec theta is equal to sec of 90 minus theta, and sec theta is equal to cosec of 90 minus theta. We can also find an interesting thing that tan 0 degrees is equal to 0, which is again equal to cot 90 degrees. Secant 0 degrees is equal to 1, which is equal to cosecant 90 degrees. And secant 90 degrees, cosec 0 degrees, tan 90 degrees, and cot 0 degrees are not defined. Now, let us move on to the topic of trigonometric identities. In general, there are three trigonometric identities. As you can see, sine square theta plus cos square theta is equal to 1 is the first identity. And the second identity, secant square theta is equal to 1 plus tan square theta. And the third identity is cosecant square theta is equal to 1 plus cot square theta. Here, we can also obtain many forms of these identities. For example, if you take the first one, we have sine square theta plus cos square theta is equal to 1. It can also be written as sine square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sine square theta. If you consider the second one, we can also write it as secant square theta minus tan square theta is equal to 1, or tan square theta is equal to secant square theta minus 1. The third identity, cosecant square theta is equal to 1 plus cot square theta, can also be written as cosecant square theta minus cot square theta is equal to 1, or cot square theta is equal to cosecant square theta minus 1. In this way, we can write trigonometric identities in many of their forms.